In this video, I'll be going over how to analyze the data from the unconfined compression test. For this lab, the lab data is not going to be given. Instead, you'll have to watch the specimen undergo the unconfined compression test and record the force exerted on the specimen. Some information about the specimen is given. The specimen is 5 inches tall and has a diameter of 2.5 inches. The water content for the specimen was 30%, and usually you would calculate the water content of the specimens of the various lab groups to see how different water contents affected the shear strength of the soil, but since there was only one test specimen, calculating the water content is unnecessary. You will read the force applied on the soil every 2 seconds for a data point. The axial displacement can be calculated based on the constant shear rate of the specimen and the elapsed time of the experiment. Read the force from the test video. After obtaining the lab data, calculate the axial strain by dividing the axial displacement by the initial height of the specimen. Assume the specimen is perfectly cylindrical and calculate the cross-sectional area of the specimen. Calculate the corrected cross-sectional area by dividing the initial area by 1 minus the axial strain. If the axial strain is a percentage, divide by 100. If it is a decimal, omit the 100. Calculate the axial stress by dividing the force applied on a specimen by the corrected cross-sectional area. Do these steps for all the data points. Using the axial strain and the axial stress, plot the stress strain curve. As is in the test name, there is no confining sigma 3 stress. So for an unconfined compression test, sigma 3 is 0. Sigma 1 will be the highest stress applied on the specimen. With these 2 points, and some equations you learned back in CE 3660, you can calculate the shear stress of the specimen. Plot a Mohr circle of the specimen, like the figure on the right. When the unconfined compression test was performed, we could see that the force being read by the load cell was not 0, even though the load cell was not in contact with the soil. When doing the data analysis, we take into account the extra force by creating an offset in the data, negating the extra force. Here in this Excel sheet, we have a sample unconfined compression test. The specimen has a height of 4 inches, a diameter of 2.5 inches, and a shear rate of 0.2 inches per minute. Our time interval is a reading every 5 seconds. We can calculate the axial displacement by multiplying the elapsed time by the shear rate. And we divide by 60 to account for the unit conversion. The axial strain is the displacement divided by the initial height of the specimen. The corrected area is the initial height of the specimen by 1 plus the axial strain. And lastly, the stress is the reading of the force applied on the specimen, subtracted by the offset, divided by the corrected area. Good luck.